right, number 7. It's a little bit trickier than some of the others because you have to know how to factor certain things. So right now, I want you guys to put a little arrow right here, and I want you guys to write this is an example of the difference of squares. I'm going to change colors. This right here is an example of what's called a sum of squares. And here is a pattern that I'm going to write down as my board resets because I need a new one. It's taking way too long. There we go. And here's the pattern for a sum of squares, everybody. If I have a plus b times a plus b, that becomes a squared plus 2ab plus b squared. This is the pattern for a sum of squares, where you have a plus b squared. A difference of squares is different. Here's the pattern for a difference of squares. This is just one example. If I have a squared minus b squared, that factors to an a plus a b and an a minus a b. So these are some rules that you need to know for the difference of squares and for the sum of squares. Now the sum of squares can also be written like this. A minus b squared is the same thing as a minus b times a minus b. And that becomes a squared minus 2ab plus b squared. These are all examples of when to recognize a sum of squares or a difference of squares. So let's scroll back up carefully so you guys can see it. There's the difference of squares pattern. Here's the sum of squares pattern. All right. Now I've written a lot. Now I'm going to show you guys how to factor. I'm holding it. All right. Clearing everything out so you guys aren't focused on the pattern. You guys have that in your journal. Right now, what you can do on this problem is simply put a parentheses around that. That right there is its own binomial factor right there. 25x squared minus 1 will factor. I'll do this one green. Will factor 5x plus 1 and 5x minus 1. If we were to do the FOIL method, we'd get right back to this binomial. This one right here will factor to x minus 5 times x minus 5. Because negative 5 plus negative 5 is negative 10, and negative 5 times negative 5 is positive 5. This right here, the factors of a 10x are a 2 times a 5 times an x. The factors of a negative 2 are a negative 1 times a 2. What's the greatest common factor between a 10x and a negative 2? The greatest common factor is a 2. So I'm going to factor out a 2, and I'm left with a 5 times an x, which is a 5x, and I'm left with a negative 1. So there's everything totally factored out. I'm going to make it nice and neat for everybody to see. I've got an x minus 5 in the numerator. In the denominator, I have a 2 times 5x minus 1. In the numerator, on the right side, I have a 5x plus 1, and I have a 5x minus 1. And in the denominator, I've got an x minus 5 and an x minus 5. I've factored everything out. Now, after we have everything factored out, we need to look for things in the numerator and the denominator that cancel to a 1. All right, now that I have everything factored, let's make some stuff bleed and cancel things out. What do you see, Madison, that I could totally cancel out that's in the numerator that's also in the denominator? Do you see anything? The 5x minus 1. Boom! Boom! Those are dead. What else? X minus 5. Boom! Boom! That's dead. So at this point, what's the only thing you see left in the numerator? 5x plus 1. That's all I see. What numbers do you see remaining in the denominator factors? I see a 2 and a what? X minus 5. And there's your answer. Right there. Now you could also see this as this. 5x. 5x plus 1 over, you could say, 2x minus 10, if you wanted to. Okay? That would still be acceptable. Alright? Or you could leave it like this. Either way, it still works. Nothing else can be canceled out. Alright, the last problem we're going to do on this video is problem number 11. And the very first thing that I would like you to do, above where it says 9 minus a squared, I would like you to rewrite it as a negative a squared plus 9. So rewrite this as a negative a squared plus 9. Notice all I did was just switch the negative a squared and move it up front. And then take the 9 and move it in the back. So I've not changed the value of the number, I've just changed the way it looked. The next thing we're going to do is we're actually going to factor out a negative sign. We're going to factor it out. I'm going to minus. We're going to open up a parentheses. And if I factor out a negative out of a negative a squared, I'm just left with an a squared. But if I factor out a negative out of a positive 9, that's actually going to make that a negative 9. Let me explain why. A negative times an a squared is a negative a squared. But a negative times a negative 9 would make that a positive 9. So here's what we have. We have a negative, open parentheses, a squared minus 9, close parentheses. That's what we have right here in the numerator. Okay? Now, everybody, I'm going to write. We just did an example of this. This is another example of a difference of squares. And remember the rule for a difference of squares is this. If I have a squared minus b squared, that factors to a plus b and a minus b. So I have a negative right here. What do you think a squared minus 9 would factor to? I'll give you it. It's going to be an a plus something, and it's going to be an a minus something. That's right. A 3 and a 3. All right? So right now, I'm going to erase this because I've already written that down before. Okay? So in the numerator, everybody, we have a negative times an a plus 3 times an a minus 3. And that's everything completely factored in the numerator of the very first part. So scroll up. What does this right here eventually become? This right here eventually becomes all of this. Now I'm going to change colors. I'm going to go red. Now this one is the easiest one, I think, to factor. Because all you got to do is look and see what two numbers add up to 5 and multiply it with 6. Not hard.
2.5.
No! 2 and 3 though, yes.
You said what two numbers add up to a I thought we had to be like the same number.
Oh, I understand. Yes, this right here, this was the same number because a negative 3 and a positive 3 add up to 0 in the middle, 0 a's in the middle. But if I said an a plus 2 and an a plus 3, 2 and 3 add up to 5, and 2 times 3 multiply. 2 and 6, and I will answer questions 1 second. but I totally see what you were thinking. All right, you were thinking of 2.5, 2.5 gets me to a 5. It had to be the exact same number. I understand your logic there. Okay. Now, the next two right here, I want you guys to do a very important thing. We're going to change this division symbol to a multiplication symbol, and we're going to rewrite this rational expression as its reciprocal. So we're going to put the 5a plus 10 up in the numerator, and we're going to put 2a minus 6 down in the denominator. Because if you remember, just from a few seconds ago, well, a few minutes ago, we learned that when you divide fractions, you actually multiply them by their what? Multiply them by their reciprocal. And your 6th grade math teacher, whoever he or she was, might have told you the old phrase, keep it, change it. Keep this, change this from a division to a multiplication, and then flip this guy. All right? Yeah. But basically, what I just tell you is multiply it by the reciprocal of the second fraction. Now, what are the factors of a 5a? What are the factors of a 5a? 5 and an a. What are the factors of a 10? 2 and a 5. What is the greatest common factor between a 5a and a 2 times 5? So circle the 5. Circle the 5. Circle the 5. Okay. Oval the 5. Oval the 5. Now let me explain to you what just happened. All right? This right here, everybody, factors the 5 open parentheses. This is the greatest common factor right there. What do I have left? An a
And 2.
plus a 2. So everybody see this right here? That's what the numerator factors. Now I'm going to go down here in the denominator. I'm going to go green. What are the factors of a 2 times an a? 2, right? 2. What are the factors of a 6? 2 and a 3. Now be careful. There's also this what? There's a negative sign right here. There's like a -1 being brought down. What is the greatest common factor between this and this? 2. So in the denominator, we're going to factor out a 2. If I factor out a 2, what do I have left? I have an a left. And what's a -1 times a 3? That's just going to be a -3. So now, everybody, I'm going to write down everything that we have. And I'm going to pause the video so you guys can see everything. Here we go. In the numerator, everything that I have in the numerator is right here. A plus 3, a minus 3, over. In the denominator, I have a plus 2 times a plus 3. Then I have a multiplication symbol right here. In the numerator, I have a 5, open parentheses, a plus 2. And in the denominator, I have a 2, open parentheses, a minus 3. Everything at this point, everything has been factored. All right, now that we've factored everything, just to be clear, what we've done, we've gone from this problem right here. We've gone from this problem and made it go from this to what? Whole bunch of work. Everything's factored. Now let's make the problem bleed. Here we go. You see this a plus 3 right here? Boom! That guy cancels out this guy. You see this a minus 3 right here? Boom! That guy cancels out this guy. You see this a plus 2 right here? Boom! Boom! Anything in the numerator will cancel out anything in the denominator if they're the exact same factor. What's the only thing we actually see left remaining? I see a negative, I see a 5, and I see a 2. And that's your final answer. I know, crazy. Let's go back. All of this, eventually, all of this became a what? 2.5. A -2.5.